Hello, everybody. Today we're going to go over lesson 8.6 on page 343 of the third grade textbook. Relate fractions and whole numbers. Our essential question that you should be able to answer at the end of the lesson is, when might you use a fraction greater than 1 or a whole number? And the math idea here that we're talking about is if two numbers are located at the same point on a number line, then they are equal and represent the same distance. So let's look at the unlock the problem and see if we can get to the point where we can understand what they mean by that on a number line. So it wants us to, Steve ran 1 mile and Jenna ran 4/4 of a mile. So did Steve and Jenna run the same distance? Okay, well, so locate 1 and 4/4 on a number line. How do we do that? Well, we shade 4 lengths of 1/4. How do we know that? Why do we use 1/4? Because it says she ran 4/4 of a mile. So we know that there are 4 1/4 parts in that fraction. So it wants us to shade 4 1/4. Okay, so now label the number line. Okay, so this point is 0 and this is 1. So this is 1 whole. This whole rectangle represents 1 mile. Okay, so here, if Jenna hadn't started yet, she would be at 0/4. She hasn't ran any part yet, right? Okay, so got to this point, that's 1/4 of the whole mile. She got here and she was halfway, or 2/4 of a mile. The next spot on the number line, she's at 3/4. And when she got to the end, where Steve finished also, she was at 1 mile. So it says draw a point at 1 and 4/4. Well, that's right here. Okay, we have 1 on the number line here, and we also have 4/4 here at the number line. So since the distance 1 and 1/4, 4/4. Let me go back then. Since the distance 1 and 4/4 end at the same point, they are equal. So Steve and Jenna ran the same distance. Okay. So when we talk about a whole number, remember that the fraction part, the bottom number, tells us how many parts are in that whole. So in this case, 4/4, there were 4 sections, 4 equal sections in the mile. All right, so let's practice some more. Try this. Complete the number line. Locate and draw points at 3/6, 6/6, and 1. So draw points. Okay. All right. So again, we have 0 and we have 1. So the top part of our number line is the whole numbers. The bottom part, we notice that the 1 whole is broken into 6 equal pieces. So when we're at 0, it's 0/6. The next part will be 1/6. So the distance from here to here is 1/6 of the whole. The next one is 2/6 of the whole. So from 0 to here is 2/6. Then 3/6, 4/6, 5/6, 6/6. Okay. Now remember, each of these parts down here are all smaller than 1 whole. The only one that's the same as 1 whole is this one right here, 6/6. Everything else is less than 1 whole. So now we have to label, locate, and draw points at 3/6, 6/6, and 1. Well, 3/6 is right there, and 6/6 and 1 are in the same spot. Okay, so are 3/6 and 1 equal? Here's 3/6, here's 1. No, they're not equal. Okay, no, they don't end at the same point, right? 3/6 ends at this point, 1 ends at this point. So they are not equal. Are 6/6 and 1 equal? 6/6 is here, 1 is here, and they both meet at the same point. So yes. Okay, so what's the explanation for that? Since 1 and 6/6 both end at the same point on the number line, they are equal. Okay, 6/6 and 1 are equal distance. Okay, so let's move on to 344. So the number of equal parts the whole is divided into is the denominator of a fraction. Okay, that tells us how many parts there were on that number line. The number of parts being counted is the numerator, such as 3/6. Okay, there was 3 1/6 parts being counted when we put our point at 3/6. A fraction greater than 1 has a numerator greater than its denominator. So in our last problem, we looked at 6/6, and it was right in the same spot as 1. But if my number was 7/6, that means I have more than 1 whole. I am starting to work on the second whole. So here's some examples. Each shape is 1 whole. Each of the parts of the whole are broken into 4 pieces. So there's 4 equal pieces in each whole. So keep that in mind. We're going to write a whole number and a fraction greater than 1 for the parts that are shaded. Well, they told us that each shape is 1 whole. So there's 2. There are 2 wholes. Now, each whole is divided into 4 equal parts, as I mentioned, or fourths. So there are how many equal parts shaded in both total? 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 equal parts shaded. So we would write 8, that's the number of 1/4 pieces being counted. There are 8 of them. Each whole has 4 equal parts. So we have 8 over 4. So 2 wholes is the same as 8/4. You can think of this as almost like a division problem. 8 divided by 4 is 2. All right, so now let's look at B. There are 3 wholes in this one, but you notice that there's no equal parts. There's just 1 equal part. The whole thing is 1. Okay, it's not divided at all. Okay, so we do know that there's 3. Each whole is divided into 1 equal part. So there are 3 equal parts shaded in all, right? So there's 3 parts shaded over 1. There's only 1 equal part in each circle. And 3 divided by 1 is 3. Okay, so explain what each whole is divided into 1 equal part means in example B. Okay, so each whole circle is not separated into more than 1 equal part. There are no lines breaking the whole circle. When we look at part A, we see that there's 2 lines splitting the whole circle into 4 pieces, 4 equal pieces. Here, nothing's being divided. So there's only 1 total piece to give. How do you divide a whole into 1 equal part? You don't do anything to the whole. So if I said we had a 1 whole square, there wouldn't be any marks on the inside of the square. It'd just be a square. Okay. All right, so let's try this. Each shape is 1 whole. Okay. And I see that there have more than one. It's not divided into 1 equal part. It's divided into 2 equal parts, each circle. So write a whole number and a fraction greater than 1 for the parts that are shaded. So how many whole circles do we have? We have 1, 2, 3, 4. So we have 4 whole circles. The denominator tells me how many parts, how many equal parts are in each whole. Well, there are 2 in each circle. Okay, so if you give me 2 equal parts and then you give me one, like a half of another one, I have more than 1/2. I have more than 1 circle, I mean. I have more than 1 circle if I have 1/2 of another circle. In this case, they all happen to be complete. So how many half pieces do I have in these 4 holes? I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 halves. 8 divided by 2 is 4. So remember, each part, based on our drawing, is saying that each part of the circle is 1/2 of the circle. And all we had to do was count how many halves. 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves. And again, they were all holes. So there was 4 whole circles. Let's continue. Each shape is 1 whole. So how many holes are there? There's 2. Okay. Each of these circles is a complete whole. Write a whole number and a fraction greater than 1. Okay, so there are 2 wholes. Each whole is divided into how many equal parts? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 equal parts in a whole. How many equal parts are shaded? Well, all of this one's shaded, so that's 8 in this one. This is the same thing, so there's 8 in that one. So there's 16 equal parts shaded. So the 2 wholes equals 16 over 8. Remember, the denominator tells me how many equal parts the whole was broken into. This one has 8 sections. So if we went around and called this 1/8, all of them would be 1/8. And all the ones in this circle would be 1/8. And so if we went around and counted how many eighths there are, that tells us the numerator. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, 9/8, 10/8, 11/8, 12/8, 13/8, 14/8, 15/8, 16/8. Okay, so we basically are counting 8 plus 8. All right, so to use the number line to find whether the two numbers are equal, right equal or not equal. 1/8 and 8/8. Okay, well, here's 1/8 and 8/8 is down here. Do they end at the same point? No. Those two are not equal. How about 8/8 and 1? Okay, well, 8/8 again is here and 1's there. They do end at the same point, so they are equal. All right, how about 1 compared to 4/8? 4/8 is here. 1 is here. They don't end at the same point. Not equal. Okay. So numbers 5, 6, and 7, use the number line and tell whether the two numbers are equal again, right equal or not equal. Okay, 0/3 and 1. Find 0/3 on the number line, find 1, and draw them. Draw a point. There's my point for 0/3, and here's my point for 1. If they end at the same point, they're equal. If they're in different locations and end at different points, they're not the same. They're not equal. So 0/3 is here, 1 is on the other end, not equal. Okay, how about 1 compared to 2/3? Here's 2/3, here's 1. They are not in the same spot or at the same point, so not equal. All right, 3/3 and 1. 3/3 is here, 1 is here. They end at the same point. They are equal. All right, number 8. Each shape is one whole. Write a fraction for the parts that are shaded. All right, so they told us that we have 2 holes. Each hole has 3 equal parts. How many total parts are shaded? 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. Remember, a fraction greater than 1, the top number, the numerator, will be bigger than the bottom number, the denominator. Okay, number 9. 1 whole circle. Well, are there any parts to this circle? No, they haven't done anything to it, so it's just 1 out of 1. Okay, this is not greater than 1, it's equal to 1. All right, number 10. So there are three whole circles. How many equal parts are in one circle? 1, 2, 3, 4, 5, 6. So these circles are broken into sixths. How many total do we have? 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. So do I really need to go 1, 6, 2, 6, 3? No, because the whole thing is shaded, so I know that it has to be 6 sixths. And then adding another 6 sixths, that would be 12. 6 plus 6 is 12. So 12 6. 12 plus 6 is 18. So 18 sixths. And if I was to divide 18 by 6, I would get 3. All right, number 11 has 2 wholes, and they're divided into one equal part. In other words, they didn't do anything to it. So our denominator is 1. There's only one piece in each of those circles. And we have 2 total. And 2 divided by 1 is 2. All right, let's move on to 346. Number 12. Draw a model of the fraction or fraction greater than 1, then write it as a whole number. Draw a model of the fraction or fractions greater than 1, 8/4. So that tells me that I have one whole and it's broken into 4 pieces. Now, there's a lot of information in this fraction. Because the numerator is bigger than the denominator, I have more than one whole. So let's draw another whole and also break it into 4 pieces. So the top number tells me I need to have 8 pieces shaded. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So how many holes is that? 2. Okay. Six sixths. Okay, this time the top number of the numerator is exactly the same as the denominator. So there's only going to be one whole. Okay. For it to be more than one whole, the numerator has to be bigger than the denominator. So here I'm going to have one circle, and I'm just going to have 6 sections. 1, 2, something like that. They're not exactly equal, okay? But we do get the idea of the 6 pieces. So 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. And 6/6, we have one whole. 5/1. So again, the numerator tells me I'm going to have more than one whole. The denominator tells me how many equal parts in each whole. Well, this one, that means there's nothing done to the whole. It's just completely shaded. Nothing's done to it. So 1 whole, 2 holes, 3 holes, 4 holes, 5 holes. How did I know to draw 5? Well, because if there's only one piece that's shaded in each one, right? That's what the denominator tells me. I have to have 5 parts that are shaded. Well, each one only has one part, so I have to have 5 circles. So 5 ones, 5 firsts are 5. All right, 15. Jeff rode his bike around a bike trail that was 1/3 of a mile long. He rode around the trail 9 times. Write a fraction greater than 1 for the distance. How many miles did Jeff ride? Well, okay, so we can do this. We know, based on this information, that every time he goes around the trail is 1/3 of a mile. So to equal 1 mile, he has to go 3 times. Okay, so this would be 0, and this would be 1, right? Okay, he went around 9 times. Okay, well, that means I need to have some more here, right? So that's 4, 5, 6 1/3, 7, 8, 9. So one time around, 2, 3, 4, 5, 6, 7, 8, 9. Well, if each rectangle represents 1 mile, he rode 3 miles. Three equals 9/3. Okay. Andrea, we got to find out what the area is here. Okay. Andrea drew the number line below. She said that 9/8 and 1 are equal. Explain her error. Okay, well, first off, since her numerator, the top number, is bigger than the denominator, that's greater than 1 whole. Okay, so how did she wind up getting these two things at the same point? There must be something wrong with her numbering somehow. So let's see. Well, what number should be with, which fraction should be with 0? She didn't start, right? So that should be 0/8, then 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. So she would have, if she had put 0/8 underneath 0, because they're equal, they are at that same point, she would have recognized that 8/8 is equal to 1, not 9/8. So what is her error? Well, she didn't put 0/8 at same point as 0. So everything is off by 1/8. 8/8 should have been at 1. Okay. And number 17. Each shape is 1 whole. All right, so we have 1, 2, 3, 4 holes. How many parts are in each hole? 1, 2, 3, 4, 5, 6. So every time I get 6/6, I get a whole number here. 6 plus 6 is 12. 12 plus 6 is 18. 18 plus 6 is 24. So now, which numbers name the parts that are shaded? Well, there are 4 holes. There aren't 6 holes, so it's not that. There aren't 26 parts shaded. There are 24 parts shaded. And there's not 6 parts. But there's not even 4 equal parts in each one. There's 6 parts equal. So that's not right. So it's just those two. 4 holes and 24/6. So that's it for lesson 8.6. In our next lesson, we'll be talking about fractions of a group. So until then, may the numbers always be in your favor.